Hello, my name is Christopher Wells, and I'm a postdoctoral associate at the University of Buffalo, working on Caribbean octocoral population dynamics. You can follow me on Twitter at the Anemone Guy. Today we'll be talking about the effects of turf algae on octocoral recruitment. Recruitment dynamics play a critical role in both structuring and maintaining diversity in communities, and in the resilience of populations to disturbances. This is especially evident for sessile organisms, such as plants and benthic invertebrates, where recruitment success is essential to recovery from disturbance, and variation in recruitment success can drive adult population abundance and spatial distributions. The roles of recruitment success and community dynamics are particularly striking in Caribbean reefs, where scleractinian coral populations have declined due to local human stressors and increasing global climatic events. Those stresses have impacted critical ecological processes such as survivorship, growth, reproduction, and recruitment. However, just as the decline in scleractinians is an inevitable consequence of failed recruitment, successful recruitment has been essential to the increased prevalence of other taxa, such as octocorals. Octocorals have always been a major constituent of contemporary Caribbean reef faunas. Octocoral forests are ecologically important, provide some of the ecosystem functions that scleractinian reefs provide, and continue to persist despite the increased prevalence of macroalgae. Octocorals have demonstrated greater resilience to disturbances than scleractinian corals, but the basis of that resilience is just starting to be understood. The most recent research suggests that the resilience of octocoral communities may be a consequence of higher recruitment following disturbance. Although recruitment is vital to maintaining coral populations, the interactions between benthic algae and octocoral recruitment are strikingly understudied, partly because of the difficulty in finding and repeatedly measuring newly settled polyps. Research to date has identified a variety of interactions between algal species and octocoral recruitment. Some have found negative effects, while others have found positive effects. In this study, we used laboratory and field experiments to quantify the impacts of turf algae, a multi-species community of filamentous algae shorter than 2 centimeters, on the recruitment of newly settled polyps of the octocoral Plexaura homomalla. We collected colonies and had them spawn in the lab, and then raised the larvae until they were metamorphically competent. Larvae were presented with tiles of one of 3 levels of algal turf cover: 1, protected from herbivores for 2 weeks, 2, taken directly from the reef, or 3, lightly scrubbed after being in the reef. After 1 week, the number of recruits were counted on the tiles. We found that recruitment was significantly reduced with increasing turf cover. On the x-axis, we have the treatments and their turf cover, and on the y-axis, we have the proportion of 150 larvae that recruited. The error bars are bootstrapped to 95% confidence intervals. These tiles were then deployed in the field for 7 weeks, where survival of the original polyps was tracked. Over time, the differences in the community structure due to treatment became less apparent and were indistinguishable by the 7th week. So instead of looking at the effect of the lab treatments, we looked at the effect of turf cover of individual tiles determined by photos on survival in the field. To do this, a mixed effect Cox proportional hazard model was used to predict the effect of turf cover on survival of polyps. Using the regression coefficient, one can calculate that for every 1% increase in algal turf cover, there is an associated 1.3% increase in the mortality rate. The x-axis is turf cover and the y-axis is the hazard ratio. The hazard ratio is the ratio of the probability of mortality relative to the probability of mortality at the median turf cover, which in this case was 39%. We've highlighted the median with a red dot. The gray filled area is the 95% confidence interval. Using this modeled rate and holding turf cover constant across 7 weeks, with no turf cover, 32% of the recruits survive. At natural levels, 23% survive, and at 100% turf cover, only 2% survive. It's quite clear algal turf has some serious impacts on survival. Caribbean reefs are undergoing a long-term increase in the abundance of octocorals while experiencing a reduction in scleractinian corals. Those changes also affect the physical structure and ecosystem services provided by reef systems. The success of octocorals, including their recovery following disturbance events, suggests that recruitment of these species has continued regardless of the high cover of algae on most reefs. However, we found that octocorals, or at least Plexaura homomalla, are not immune to the negative effects of algal turf. Turf algae, even at low densities, significantly inhibited recruitment and survival of recruits. The mechanisms for this inhibitory effect are still unknown, but understanding the process will be important as further declines in scleractinian cover, where they are still abundant, may lead to more octocoral-dominated communities in the Caribbean. Thank you for taking the time to listen to my talk. If you have any questions, please feel free to ask me at the end of the session. And if we run out of time, you can contact me at my email or on Twitter. Have a good day.